Good morning, guys. Once again, I find myself apologizing for having taken so long between recording this session and the last one, but I've had loads of silly life problems, like my wife's car blew up. My dogs keep escaping into the farmers' fields next door where there are sheep. So I've been fixing cars and, I hate to say it, but putting up an electric fence to stop my dogs getting through. I've fenced the entire property, but one of my dogs, it turns out, thinks he's a rabbit, and keeps trying to dig, well, not trying, succeeding in digging under the fence. So I've just given up, put a electric fence tape along the bottom of the fence. I haven't turned it on yet. I haven't introduced them to it yet, but unfortunately needs must, because the farmer got very irate. And of course, well, I don't know what it's like elsewhere, but in England they keep saying things like, "You realise I can legally shoot your dog if he gets in with my sheep," and I don't want my dogs to be shot. Anyway, fixed the car, almost finished the fence, not quite, I'm working on that. So what now? Okay, so we're now going to look at actual virtual machines and Linux containers, which is a nice, interesting topic. Taken us a long time to get here, but I wanted to really set the basis for what we are slowly leading up to. So let's have a look at where we go, where we've been, and where we're going. Okay, so we discussed, an overview of exactly what Proxmox is. I gave you a demonstration. We've played a little bit with the web user interface. We've done an initialization and an installation and initialization of the cluster. And we, sorry, of a single node. And then we went on and we created a cluster, which is not how most people present this subject. They tend to bring up clustering later on, but I don't know. I think you'll find it was fairly intuitive, relatively simple to do. And we also discussed briefly the quorum mechanism, but when we come to do HA, high availability, which is in fact going to be the next topic after this, then we will revisit quorum. So it's all exciting stuff. So today we're going to look at virtual machines and Linux containers. Okay, so first of all, I thought a brief sort of overview of Linux containers and virtual machines and what the differences are and why you would choose one over the other. Now, it's actually quite a difficult decision in some ways, and I must admit, my default behavior is just virtual machines. I prefer them, they're easier. Well, are they? They're not actually easier, but I kind of understand them better, or I feel as if I do. So what are the differences? Well, one of them is a virtual machine is basically a complete installation of an operating system, be that Linux, Unix, Mac OS, Windows, etc., etc. So it's totally self-contained. It's known as a kernel-based virtual machine. That's what it's using, KVM, which is part of the kernel of our PV, well, part of the kernel of Linux. By default, you don't have to install it or anything. And so our virtual machines actually effectively, if you think of an operating system as layers, our virtual machine goes right to the bottom of the layers, runs its own kernel, runs its own operating system applications, etc., and just uses, you could almost say uses the same hardware that the Proxmox nodes uses. Okay, of course it can have, our virtual machines can have different IP addresses. We can feed through things like GPUs to virtual machines. So we've got massive flexibility. Now, unlike that, a Linux container actually shares the kernel of the Proxmox machine. Okay, so that by definition means you've got to run Linux in a Linux container. You can't run Windows in a Linux container because it's using a Linux kernel. But you don't have to use the same flavor. So you don't have to be using Debian or Ubuntu. You could be using Rocky Linux or Mint. The list is endless. As long as the kernel's compatible, which, if you've chosen a version of Linux which is using a later kernel, which is highly likely, then it will be compatible and it will work. So it shares the kernel, which by definition means it uses less resources. Okay, so it uses less CPU power, it requires less disk space, And on the surface, at least, it looks like a much better choice. Okay, it's more efficient, etc., etc. So that makes them interesting as well. Okay, boot speed. Yeah, I'm not sure how important boot speed is, but actually, uh, Linux containers start pretty much instantly, whereas a virtual machine obviously takes longer to boot. This means if you migrate a Linux container, it tends to be available much quicker than a virtual machine. Having said that, the virtual machines are pretty quick anyway, as long as as long as you're using shared disk space. If you're not, if you've got two nodes in a cluster, for instance, not recommended, minimum 3 is recommended, but if you did and you migrated a virtual machine from one node to the other and you were using local disks on those machines, then obviously it's got to copy across the virtual disks, and that can be quite slow. But if you're using shared disk space, then when you do a migration, all that happens is the second node that you're migrating to picks up the disks from the shared storage. So that's, quick. And I also point out, by the way, with Linux containers, you cannot migrate them unless they're on shared storage. So fine. The other point that's often made, difference between virtual machines and Linux containers, is that Linux containers basically have poorer isolation between other containers and the Proxmox host, whereas virtual machines are much more isolated. So why would that matter? Well, it depends on your security risk aversion, as it were. So if virtual machines would be considered to be more secure, and Linux containers would be considered to be less secure. Okay, so which is a negative statement, but if you've ever met a security specialist, they're always on the negative side, be paranoid. So yeah, what other points here? Live migration, yeah, it is supported, which is brilliant, very quick. And the whole context is migrated. So if you have a session running and you have connections, let's say it's running a Windows server and you have external connections, then the memory is also migrated across. So those sessions will be maintained. That's really good. And that's what you want, of course. Um, and then compatibility, well, the Linux containers only run Linux distributions, but be aware that means pretty much any Linux distribution. So it's pretty flexible. So if Linux is your thing, then containers are a good thing to consider. Whereas virtual machines can run any operating system that where there is a version for the underlying architecture of your Proxmox servers. So for instance, mine are running on these little HP things. Therefore, they're running on x86, Intel or AMD processors. So as long as I can get a version of an operating system that runs on either on Intel or AMD, then it should work fine. If, for instance, if you set up a Raspberry Pi cluster, or single node, then you would have to find ARM distributions of whatever operating system it is that you would like to support. Okay, so that's a brief overview of the difference between virtual machines and Linux containers. So it's down to things like performance, isolation, flexibility. In other words, you can't run Windows in a Linux container, etc., etc. So which one you choose is entirely up to you. Like I say, my default tends to be virtual machines, but for no particularly good reason. But that's your decision. Okay, so let's start off by looking at virtual machines. Okay, before we can actually install an operating system on our new virtual machine, we need to download an ISO image of the operating system which we wish to install, be that Windows, Linux, macOS, whatever. Okay, so the first thing we need to do is actually decide where we want to store that image. So let's go to our web user interface for our cluster, okay, or our single machine if that's what we have, which is fine. Okay, log in, and first thing we need to do is go to the data center, storage, and find the storage that we're going to use. Now, in my case, I'm using shared storage. So I'm using NFS, and the storage where I want to store my ISOs is called Kukang VMs. Now I need to check that I've actually enabled ISO image storage. So I need to check that it says here, amongst other things, it says ISO image, which it does, as it happens, because I've already installed or downloaded a lot of ISO images. So if it doesn't, all you need to do is double click on it or highlight it and click on edit, and then just go to the bit that says content, pull the download, down pullable menu, and make sure that ISO image is selected, which in my case it is. So now we have support for ISO image storage on that device. Right, now we need to go to that storage itself. And this, until you get used to it, is a teeny bit confusing because you think, well, it's here, surely. But it isn't actually. Go to any node in the cluster. So I'll pick one at random. Cobra. Could have picked any of them. Find the storage, Kukang VMs. Click on that, and you can see here there are a number of tabs. Remember, the way it works is when you drill down to something in the left-hand side, then the tabs relate to that particular object. So I've drilled down to Kukang VMs, so I can click on ISO images. Now I've already installed or downloaded a lot of ISO images, okay? Amongst them is Ubuntu Live Server. Now, actually, normally if I want an Ubuntu desktop, what I would do is actually install Ubuntu server and then simply do an apt install gnome-desktop, for instance. However, for this demonstration, originally I was going to go to Rocky Linux. So I started recording this section, went to Rocky Linux, and there's obviously, at first I thought it was my end, but there's obviously something seriously wrong with their download server at the moment, because despite the fact that I've got a 1 megabit feed to my house, it was telling me it was going to take 23 hours to download. Having said that, it's Sunday morning at 6 a.m. Here in the UK. So I don't know where Rocky Linux is based, but maybe they're doing maintenance on their servers or something. Although normally they tell you, don't they? So anyway, um, I gave up on that idea and I thought, well, I'll just download Ubuntu Desktop. Okay, I've already got Ubuntu Live Server, which is just the server with no desktop. But if we go to download Ubuntu Desktop, click on that link, we'll download this 6 GB file. All right, well, I've already done that. So in my downloads folder, I have a copy of Ubuntu. So what we can do is just simply upload. Now you can download from a URL. So you can go to a site, copy the URL, and then try and download from that. Just be aware that very often download URLs are not clearly easy to find. You go to a website, for instance, I'll demonstrate this. You go here and you click on right-hand mouse button and select copy link, and you think, okay, this is going to be fine. So you now go to download from URL, paste in the link you've just copied, but it's obfuscated. It's not a link to the ISO. So if you look at this, this is evidently not an ISO file, so this would fail. If I try and test it, it's going to come back and say, thank you. Well, no, I don't think that's correct. That should have the actual file name. So it doesn't always work, like I say. And if we do actually try and download it, it comes up and says, no, no, dude, this ain't right. Okay, so let's get rid of this. But that does work, but I mean, simpler is just to download it to your PC or your Mac or whatever, your Linux machine. And once you've downloaded it, click on upload, select the file, go to downloads, and lo and behold, there's our Ubuntu desktop. Double click on that. Okay, it fills in the file name for us, tells us how big it is, and we click on upload. Now it's 5.9 gigs, so it's going to take a minute. So I'll just pause for a second while it uploads it. Okay, it's very nearly finished. Okay, and as we can see, it has successfully downloaded. This last part here actually does take a while, because what it does is it caches the download and then copies it into the target directory. So this might take a little longer than you expect, especially with a large file. Like the Ubuntu desktop is actually 6.34 gig. So be prepared to wait a second and do let it finish. If you interrupt it, so on that previous window we just had, if I'd actually aborted out of that, then we'd find that this wouldn't be 6.34 gig. It would be there, but it would have not completed successfully. So in this case, you need to wait for the task. Okay. And we now have successfully downloaded our ISO image, which we can use in the next stage. So the first thing we're going to do is go across to the web user interface. By the way, it is possible to create virtual machines on the command line. In fact, it's possible to do anything you can do in the web UI on the command line, but it's probably unusual. You probably wouldn't do that unless you were doing batch jobs where you were creating multiple virtual machines. So you might have a script for disaster recovery, for instance, to recreate the basic virtual machines, empty virtual machines that were lost in a disaster. And then as long as you can actually recover the storage from your backup team, your storage team, then you will be able to reinstantiate those missing virtual machines. Okay, so the first thing we're going to do is log in as root. But let's actually make this so you can actually read it. Okay, probably going a bit too bonkers here, but still, I'm going to shrink the log down a bit so we've got more on the screen. Okay, so I have actually got a number of virtual machines and containers built on here. In fact, I can't remember what's on what, but anyway, okay, so here's a Proxmox node Cobra. Just make sure it's got 16 gig of RAM, so okay, it's got plenty of capacity. So how do we create a virtual machine? We go to the node we wish to initially create it on. We do a right-hand mouse click, and choose Create VM. Or we can go across to the top right of the screen. Hang on, let me move myself out of the way. Whoops, that's not me. I'm moving the wrong thing. Move me out of the way. There we go. Or we go across to the top right-hand side of the screen, and we can click on Create VM. They both have exactly the same effect. Okay. So Create VM, and you'll see there are a number of tabs across the top of the screen. So as we complete various bits of data, then we will move across until eventually we get to the end where basically we can review what we've said and then confirm it and create a virtual machine. Now the virtual machine ID starts at 100 and increments. Not sure what the limit is, but it's very high because, for instance, I've used this in the past to indicate a particular type of server or a particular location of a server. So for instance, we could decide to have a VM ID of 2000. And that might mean site 2, building 2 or something. It means something to me. Okay, got to give it a name. So let's call it VM test. Actually, I think I've used that before. So I'll put VM test 3. I think I've got a VM test 2. So we just pick a name. Resource pool we'll cover later, but basically allows us to group virtual machines together. So we're not using that at the moment. We can either click on next or click on the highlighted OS. Okay, so we're actually going to say we're going to use a CD DVD image file, ISO file, to actually create this from. And it's important here to make sure you notice what the storage says. Now, it did say Kukang VMS, or VMs, I should say, which is my NFS storage where I plan to store virtual machines. And ISO image. Okay, so I've got a list of ISO images here. And as you've seen, you can upload them in the GUI or you can simply copy them across. Okay, so what are we going to install? I don't know, let's install Ubuntu 24.04 server. Okay, what is it? It's Linux, but here you can choose Microsoft Windows. And if you chose, well, we're not going to, obviously. If you chose Windows, you can specify what release of Windows. So Solaris, which is Sun Microsystems version of Unix, fantastic operating system, as is Linux, as is Microsoft. Yeah, as is BSD. These are all lovely operating systems, but we're going to choose Linux. And we're using the latest kernel, which will be 6 point something or other. It's certainly higher than 2.6, but it does support even earlier versions of kernel. So that's all fine and dandy. So here, graphics card default. In other words, we're going to use the graphics of the server itself. Later on, we could look at passing through a GPU. Obviously, couldn't do it on these because I haven't got a GPU on those. I do have a 3070, I think, 3080 on another machine that I could demonstrate it on there, although it is in use for something else at the moment. Okay, the BIOS that we're going to choose is either UEFI or CBIOS. And I found that CBIOS is the most reliable, so I'll leave it at that. If you define UEFI, then we're going to need an additional disk. which effectively emulates the NVRAM of UEFI. Okay, SCSI controller, we're using VirtIO, which is a para-virtualized SCSI driver, which gives us really good performance. Now, there are other options, as you can see. Linux supports VirtIO out of the box, and at least recent versions. And if you come across if you decide you're trying to install an earlier version of Linux, then it is just a package that you can get from Fedora, of all places. But in fact, for some time now, VirtIO has been included in Linux. Now, in Windows, I believe I'm right in saying, and I don't know about Windows 11, but certainly up to Windows 10, you actually had to add the VirtIO package, again, which you can download easily. Okay, the QEMU, or QEMU, actually, I never know how to pronounce that, but this is an agent that can run on this server. And what I'm saying here is, yeah, we're going to install that agent, and that actually just means that, for instance, when you come to try and shut this down through the GUI, then Proxmox is able to communicate with this virtual machine, communicate with the agent, and actually arrange for the machine to be shut down gracefully. Also, you get a few extra little goodies. So, for instance, when we create this virtual machine, in the summary page, we'll be able to see what its IP address is from the web GUI, which we would not otherwise. We'd have to go into the virtual machine to find out. Okay, we're not going to add the trusted platform module. That is a security thing which is beyond the scope of this course. So, but if you know about those things, that's something you can decide to do. Disks, okay, we're going to use SCSI 0. Again, important to note, make sure you choose the right storage here. Okay, but the device number is probably irrelevant, but you can change it if you want to here. Disk size, obviously you need to decide how much. 32 gig is more than enough for a Linux install. 16 gig or even less actually would be fine. Okay, format, there are various formats that you can use. So we're not going to use a raw disk format for a bootable operating system, but it's there. So it could be, you could be actually setting up a disk for a database, for instance, and they often use raw disks. You can use VMware image format, but the QEMU, by the way, stands for Quick Emulator. The QEMU image format, GCOW2, is the preferred for, well, unless there's some strong reason for not using it. CPUs, so we can choose how many CPUs. We'll go insane here and give it 2. Although it's a Linux server, it'll run fine with 1 core. And then we can choose CPU type, of which there are billions. This is the kind of default that you're always offered. x86 64-AES. It works for me all the time. And by the way, you can change this afterwards. So you can create the VM, you can install it, you could run it, and then find out you've got an issue and you need to change the CPU. Not a problem. You'd have to shut the machine down and power it off to get the change recognized, but you can make changes there. Okay. Memory, well, that seems a bit mean. Let's give it 4 gig. Okay, and network. VMBR0 is a virtual bridge used for virtual machines, and so we will choose that. Again, we may have created, if we check, we'll see there's nothing other than VMBR0. But if we have multiple network interfaces on our Proxmox servers, we could choose, and we created multiple bridges to connect those multiple interfaces. We could choose one here. Okay, and again, we're going to use the para-virtualized or the VirtIO network driver, which is the most efficient for a virtual environment like this. And this is installed by default on Linux. And as I say, you need to check out on Windows. But from memory, I think you have to install it separately, but that's not a problem. So finally, we can check this out. So we're going to run the agent, 2 cores. This is the CPU we're going to use. This is the CD-ROM on a pseudo IDE drive, 4 gig of memory, name of the machine, the network, VirtIO, node name, Cobra. This is the name of the server upon which we are installing it initially, but it doesn't have to stay there. We've decided to call this machine VM test 3. But that doesn't mean within the operating system that we have to call it that. It's sort of recommended that you do, otherwise it gets very confusing. So you'd have a virtual machine called one thing, and when you booted the virtual machine, you'd see the host name was different if you chose to do that. So I think that's a little bit strange to make that choice. But yeah, we're initially installing it on Cobra. Um, I was just looking down, anything else? This SCSI interface, GCOW. Our SCSI hardware is going to be VirtIO SCSI single. We're going to use one socket. We're using 2 cores, and our virtual machine ID is 2000. So we click on finish, and this will be almost instantaneous. And now it's basically up and running. So we can go to console, and we can see the machine is not running, which is what this is demonstrating here. So we've created our virtual machine, but it obviously doesn't have an operating installed on it yet. So if we started, we attached, in fact, if we go and look at the hardware, we attached to the CD drive, or we inserted, if you want, a virtual CD into the CD drive, which was the Ubuntu installation software. Okay, so if we go to the console and click on Start Now, what we should see, hopefully, is that we will boot from there, and yep, fair enough, up it's come, and it says try or install Ubuntu server. So we'll say yes. Okay, so we've successfully installed our virtual machine. I'm going to do an install of Ubuntu server. I'm then going to follow that up by patching it. I'm then going to install the QEMU guest agent. And I'm also then going to update it to actually have a desktop environment as well. So I've done this a couple of times, and I've tried editing it and fast forwarding it and things like that, and it just ends up a total mess. So what I'm going to do is go through the whole process real time, talking my way through it, but I'm going to pause the long delays rather than try and high speed it. I tried high speeding it; it's just a total disaster. So let's have a try at doing that. So we'll go across to the cluster, and here's the machine that we've just installed, VM test 3. So we can start it. Well, let's go to the console, click on Start Now. As I say, I'm going to do a lot of editing afterwards, but we're going to try or install Ubuntu. Now I'm going to cut out most of the boot sequence because it's a little long-winded. Okay, so we've got to the point where it's asking us what language we prefer, so we choose our language. So I will choose English UK. It's then asking us, do we want to update to the latest installer? The default is not to, but I will. Why not? Now it's asking to confirm the keyboard, which is correct. And what would we like to install? We want to install Ubuntu server. There is a minimized version, which is probably better for security reasons, and you could always install that and add packages as you needed them afterwards. We're now going to configure the network. I want to use static network, so I'm going down to the network interface, hit enter, go down to IPv4, hit enter, and hit enter again, change it from automatic to manual. And at this point, I will now enter the relevant information. Okay, so I've completed all the fields. So I've put in the subnet, which is 192.168.0.0/24. That's the CIDR, or the net mask, indicating this is what used to be called a Class C network. I've given it an IP address, a fixed IP of 246. My gateway is 0.1. I've entered 2 DNS servers, 1.1.1.1, comma 8.8.8.8, and I've put the domain as example.com. It's now asking me for a proxy server. I do not have a proxy server on my network, so I'll just click Done. It is now testing that it can access the mirror for the repository. That's succeeded, so I will hit Enter. And it's now asking me what I'd like to do with the disk. So I'm just going to choose the default, which is use the entire disk. And I'm also going to choose the default, which is to use Logical Volume Manager, LVM. because that gives us all sorts of features that we can use later, we'll cover later in the course. So we'll click on Done. So now we've got a summary of what we've asked for. So it's important to check at this point because you can still go back and modify anything that's wrong. I'm going to click on Continue. It's warning us we're going to lose all our data. And it's asking me for details of a user who will be the sudo user, the administrator effectively. So I'll now fill that in. So I filled in all the relevant details and I will click on Done. We now have the option to upgrade to Ubuntu Pro, which is a subscription-based distribution, but we're not going to choose that. It's asking me, do I want to install SSH? And the answer is yes. So I hit the spacebar to select that. I can also optionally import my public key from my Mac, but I'll leave that for the moment, but it's intuitive, easy enough to do. Click on Done. Do I want to install any additional software? Not at this point. I can do that anytime I want later on using the apt command. And it's now actually doing the installation, which will take about 10 minutes or well, that was a little bit like watching paint dry. I'd normally go and get a cup of tea, but the installation finished. It took about 10 minutes, like I said. So now we can either view the full log, which can be useful if something went wrong, or just reboot. So we'll reboot, and again, I'll cut out some of the boring bits. At this point, I managed to cut out some of the interesting bits. So what you're seeing, or will see in a second, is actually the update process taking place. What happened was I paused the recording and forgot to restart it. So all I did was type in apt update, which updates the repository cache, and then apt upgrade -y, and that does the actual upgrade itself. Sorry about that. So I've done an apt dist upgrade. I'm not sure if you saw that. I might have actually messed up. So this is now doing an upgrade after we did the update, and we'll come back when it's finished. Okay, you can't get the staff. I think I paused the recording when I did this. I did, well, let me clear the screen so you can actually see. The upgrade has successfully completed, as you can see. What I actually did was an apt update followed by an apt dist upgrade with a -y, which saves me typing y when it would prompt me to say, are you sure you want to continue? So as we've just done a major update, I will now reboot the machine. Either reboot or technically correct would be to do a systemctl reboot, but they are actually the same thing. Again, I'll pause the parts of the reboot which are a little bit monotonous. And we're now able to log in again. So I will log in. I'm now going to install, as root of course, the QEMU agent. So we do an apt install QEMU-guest-agent. I'm now going to power the machine off because in order for Proxmox to see that we have the agent installed, we need to actually power the machine off and restart it completely. Okay, having installed the QEMU agent, we can now check that it is actually enabled. So if we go to options, and if we look down here, we can see QEMU agent is enabled. If it was not, then we would simply tick that box. But it is enabled because when we created the VM, we ticked the box that basically said enable it. So if we go back to the console and oh, right, let me show you. If we go to the summary, at the moment, it says guest agent not running. So after we've installed it, after we've rebooted, we'll have another look. So go click on start now. And again, I'll pause all the boring boot up stuff. So we have now successfully rebooted, so I'll log back in. And if we go to summary, which we did previously and saw that no guest agent was enabled, what we now see, and this is one of the things that guest agent allows us to see, we can see the MAC address and the IP address. Okay, so that's the benefit of having the guest agent installed. Also, we can go to the machine and we can choose to do a shutdown, and Proxmox now knows how to do a graceful shutdown of that server. So let's return to the console and let's actually do another step which may be of interest to you. Now, we actually installed Ubuntu server, so if we'd like to change our minds, as it were, and install the desktop environment, the default one being Gnome, then we can do an apt install Ubuntu -desktop. And this is going to take a while, so I'm actually going to pause it again. It kind of gives you an idea of just how much disk space and resources a windowing or desktop environment actually takes up, which is why servers in data centers do not run desktop environments. Okay, so it's finally finished. So we now need to check that it will actually run if we reboot. So we do a systemctl and we do a get-defaults, or default, I should say, and it's coming back and it's saying graphical target. Okay, if it said multi-user target, then it wouldn't run the GUI after we rebooted. So I will now do a reboot. And pause it again. And finally, we are here in the graphical interface. I think it's great for laptops and things like that, but for virtual machines, unless you've got plenty of CPU resources and disk space, I would go with a server install. Now, I think did we give it one CPU or maybe two, but either way, you know, it was quite slow even just booting that. So, right, it's now just selling me stuff which I'm not interested in. And in fact, what I tend to do is open a terminal and work in a terminal anyway. So the only place I've got a desktop installed with Ubuntu is actually on my laptop. But I hope that was an interesting exercise. And that pretty much completes our virtual machine installation and Ubuntu installation. So I hope you enjoyed it. If you did, please do tick like and subscribe, because it helps me get my stuff out there. There's not much point doing it if nobody watches it, is there? All right, well, thanks for your time. In the next section, we'll be covering containers. So hopefully I'll get that out very soon. I know I always say that, and then it's always a week or more before I do it, but this time I'm determined. All right, thank you. Bye, everyone.